So today we'll have an interesting session in front of us. We're gonna fine tune a model using Hugging Space, and then move to that model and deploy it. Not deploy it, sorry, to push it to the Hugging Face, so you can start creating your own portfolio. Yeah, that's the goal for today. I'm gonna share my screen now, and then we can jump straight to the coding session. The goal for today, as I said, is to implement a Hugging Face model, of course, use the pre-trained one, and then fine-tune it on a data set for finance. And the goal for today is to train it so we actually get to predict whether or not some finance information is positive, neutral, and so on. So it's going to be interesting, and that model can be used for different things as well. And at the end, you will have the first model pre-trained pushed to Hugging Face, so you can start building your own portfolio. And the goal for us, all of us here and everybody that's gonna watch this session live, not live, pre-recorded, is gonna be to build our own portfolio. And besides GitHub, one of the best spaces to build your portfolio is Hugging Face. Everybody that's trying to find a job in AI industry is pushing their models, projects, and stuff like that, and then potential employers are looking for those models and projects there. So let me open my Hugging Face account right now, and I can show you right there what I meant by that. So toggle share screen. When I'm gonna log in right now, let me do that fast. Okay. Amazing. Thanks. So when you are on the Hugging Face, you can basically go models, and then I have a couple of private models that I tested out. So we're gonna create a third model for my account, the first model for you, and at the end you will have something similar to this one. Don't worry about model cart and all documentation. I'm gonna walk you through everything right here, so you will know what to watch, what to change, and what is the good documentation for your project. Because later when we start digging out some repositories and stuff like that we would like to build for ourselves, this is a great place to be. As you can see, it's in inference there. I can actually write from this model. I can classify text. That's our goal. So yeah, basically we'll have the same thing for your own account. Okay, so because we can this is due to me not being live on this, but yeah, you can start using Hugging Face without having an account. So the first step for you today is to create your own account. So if you go to huggingface.com, let me paste the link in the chat. Jerome, hi. Thank you for running the session. Unfortunately, I can't stick around this time, but definitely catch up. No worries. Please let me know in the comments later when we publish the session if you have any questions. So thank you for jumping in. So please go to the Hugging Face and sign up. It's really simple with your email and address, email and a password, and yeah, just continue and create your own account. For me, I'll log in, and it's pretty straightforward to log in and create your own account. You will have a similar interface to this one. Once you have an account, you need to start a free or empty Google Colab. So I'll wait for a couple of minutes, and please let me know in the comments, in the chat, if you have your account with the Hugging Face created, so we can continue. If not, no worries. We can stop by later when we kind of finish the session, and then you can post there. So do you guys already have Hugging Face account? Some models from the Hugging Face, like Llama 3, Llama 2, and stuff like that, do require us to have the account because, yeah. Okay, just created. Amazing. Please, guys, do create it. Great. Thank you so much. So let's go to this. I can share actually this with you right now, and you can follow along with live coding. Anyone with the link, copy, done. So here is the work session that I'm gonna fill in during this session. So you can just create a copy out of it, or yeah. And at the end of the session, in the comments, I will provide the full link with the code, so you can follow along with the recording as well. So before we start this whole environment, for us, we need to move this notebook to GPU because CPU for us today is too slow. So this is a free version. I downgraded my account to free version, so I will have the same version as you. Select T4 GPU and then click Save. Connect, and you are good to go. Once you're connected, you will need to install a couple of libraries for us to work. So the first library is, of course, transformers. Install transformers. Then I'm going to install datasets. Then I'm going to install again transformers, but with the one interesting change, and that you should put like brackets and then put torch like this. So we are installing the engine. Maybe you don't need to install it twice, but for me, for some reason, it didn't work if I just install this version. So I make sure that everything works. Then datasets is for us to work with the dataset, and then transformers is basically to create a torch version of transformers. It will create some interesting libraries, some interesting libraries in the backend for us that are only available through torch library. So basically that's what we are going to do right now. Paste the code in here. I just sent Alexander. I just sent the link to the code. I can paste parts of the code in the chat if you want, but this is the only code that I just created so far. Here we go. Yeah. Okay. So this will take maybe 30 seconds or so because it's installing all the drivers for NVIDIA. So we need those drivers to be able to train the network on GPU as well. So that's our first step. After that, we need a couple of things to define. The first step is, of course, to work with the data set. So please let me know in the comments or in the chat when you're done installing all the libraries, so we can continue. For the time being, I'm just gonna say preparing data set, and I won't continue coding until some of you already finished installing, because of course I want to wait for you. But while we wait, I'm going to show you the data set. So the data set for us is finance emotions. And let me data set Hugging Face. Okay, this is the one. Vamo. Okay, this is a big one. let me change again. Vamos YD. Okay, so this is the data set. It has like a set of classes, like categories are neutral, happy, sad, anger, disgust, surprise, and fear. And these are all the libraries from this emotional data set. And basically there are a couple of tweets or texts and stuff like that we'll check out right now. But basically you will work towards that everybody that someone writes to the moon like this, you would like to see and check and check basically if that data is positive, net neutral, negative, sad, and so on. I'm gonna copy the link to this data set right now. This is happy. And this is the full data set that we're gonna work with right now. Here's the data set. Okay. And basically that data set can be imported really, really easy in one line of code. I'm gonna provide the link URL, dataset URL in here as well. Okay. So from datasets, import load dataset. Oops. Data set. Okay. And the dataset name is gonna be Vamo SSYD / finance emotions. This is the dataset name. And I'm gonna paste that in the chat as well. Okay. So once we define the dataset name, we need to load the dataset. And there are many ways to load the dataset with a Hugging Face. And if you just load the dataset like this, dataset name, you can. However, the problem with this approach, you will see it will take like a couple of minutes. You will see that the guy who created the dataset didn't think about us and the need to train and test the model. So in this case, we have a dataset that only has a training part, but we need some part of the dataset to even test to our model to see if it actually works or not. So to create our training set as well as the test set, we can, and there is an interesting way to do that, by providing a second argument to this load dataset function, and that's called split. And this split takes as an argument or as a type called a string. And you need to provide a train, and this is this one. So if this is called training or trained or whatever, this split under quotes should be equal between these two. Now, Hugging Face allows us to say, okay, I want first 90% to be like a training set. And then I want to do the same thing, but instead of the before, I want to put after. So this is a great thing because we can put actually a percent and then say the first 90% of training data will be the training set, and the rest, the last 10%, will be a test set. Now, of course, we need to preserve there in some variables. So this will be train data set, and this will be test data set. And here we are. We just loaded two parts of a data set. Just to understand what we just got, let me visualize the training set. As you can see, 9,000. And if I take train data set from some sample, here is our sample. Body is board committed another fraud. Tapper will make it bleed to death. Then clean text is basically our cleaned text, which is just some changes that they wanted. And then here label is call disgust or anger, depending on what we want to achieve. Okay, so this is basically what the single sample in our dataset will consist. Now, because we have two different labels that we can choose from, one is called label, the second one is called ChatGPT label. I'll show you both ways on how to choose which one you would like to use as a label for our model. But in this case, we'll go with a label because it's kind of what people wanted us to use. Now, can you please zoom in? Of course, let me zoom in. Thank you so much for mentioning that. I forgot. Is this better? Uh, I'll switch there, and please let me know, is this better right now? Yeah. Okay. And amazing. Should it be in Hugging Face or Collab? No, we are just right now working with Collab, Phil. Um, we'll later push everything that we've done so far to Collab, yeah, to sorry GitHub, and then as well as Hugging Face Hub. But right now we will work everything in the side of the link right here. So let me paste the link again to the chat. Here is the link. Yeah. Guys, have you managed to copy these parts and implement these parts so far? Are you managed to? Did you manage to? Sorry, work out the data set? This is the code. I'll keep it there as well. Yeah. While you're trying to copy that, I'll create a new section called tokenizer. And let me check if it's being synced. So no need to copy. Okay, great. But please let me know if you are following along and implementing yourselves. Please let me know, and then I will stop and check it out. Cool. Okay, so the idea of this is right now we need to transform this kind of a text into some numbers, and that's called tokenizer. And tokenizer has many different ways to be implemented, especially with Hugging Face, and there are many different tokenizers that we can choose from. For today's session, we're going to use one of the most common models used for text classification, and that's called BERT, still one of the best in the world for this type of task. So from what I'm going to do first is from transformers import auto tokenizer. And the next thing is, of course, to define tokenizer. That's going to be auto tokenizer dot from pre-trained, and then underneath these quotes you need to define which tokenizer you would like to define. Now in my case, because we are using the BERT model, I can define a BERT and then base cased. Now this is a name of a BERT model that is most case used because it is actually taking care of casing, like uppercase and lowercase as well. You can import uncased, which use everything lowercase. Okay, so are there any questions? It's being synced, but you need to reload to get latest. Yeah, yeah. Unfortunately, you need to get to reload to that. Yeah. Okay, so this is our tokenizer. Now you need to bear with me for a couple of minutes, and then I'm gonna roll back and see if everything so far you followed along. So right now we need to implement one function that will tokenize our batch of data. So, or basically our data. And then we need to implement a mapper that will take, for example, a name, because let me show this to you. So we have right now train dataset, and if I use one sample, you will see that label is actually a string. And that's not great for us because we need to have this string to be 0, 1, 2, 3, 4, 5, or 6. So to do that, I'm going to implement some simple dictionary called str2int, and this will have a couple of entries. For example, 0, copy and paste to make it faster. So this is going to be 1, 2, 3, 4, 5, and 6. So of course, because we are starting with 0, we don't have 7. Now the first one is going to be neutral. Now, does order actually matter? Not really. So you can put sad here, neutral here. You can play around, but for me, it did not show many big differences in the training part later. Then anger. Then here we have disgust, and then here I have surprise. After that, we have fear, and then finally we have happy. So this is, let's comment out, and here is our mapper. Now, because we have this mapper, we need to define our tokenize function. And this tokenize function, you can name it whatever you like, will take a batch of data, and the batch of data is set of samples pushed together. So we are not sending one by one, like a train data set 100 and then 101 and so on, but we are sending maybe like this. So 100 to 125. And let me showcase how this actually looks like. So if I push this here, you will see that there are many different samples that works together like this. Okay, so many different samples. Now the batch size, it really depends on whatever you define. For most cases, it's going to be 25 to 45 different samples at once, but you will let it by itself to determine which batch size it will take. Now, in this function, I want to perform two things. The first thing is to call our tokenizer on our cleaned text and then tokenize it so that we can actually push it to the model. And the second one is to match our label from string to integer, which is this one. So this, what I want to do right now is tokenized batch is equal to tokenizer, and this tokenizer is whatever we defined right here. Okay, and then it will take batch cleaned text. Okay, padding will be max len, and then truncation is equal to true. Okay, so let me first walk you through all of these parts right now. Now, what I have in here is this. The first thing first, what I do is basically, let me just handle this padding. Okay, and here it is. So I'm taking my batch of data that we pushed to this function. We'll take clean text as an argument, and then we are performing tokenization of this data. So it will be like from text to string and so on. From not text to string, from string to integers as well, and so on. Then padding will make sure that everything, like all 25, 30 samples in the same text, is going to be equal. Now, if you don't know what the padding is, let's define something like this. So imagine that you have a sentence that looks like this: I love ice cream. And then I teach ML and AI and I love it. Or I love you. Okay? So you have three different sentences. You have one that has 4 words, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9 words, and then you have 3 words. So if you push all of these together, BERT will basically throw an error and say, oh, I can't recognize which sentence to take. So what we can do is define what is the max length of a model. Let's say it's 6 words. Now in BERT case is 512, but in this case, let's say it's 6. So you have 4 words here, and what the tokenizer will do will add 2 zeros because you have 2 more words than it can support. Now in here it will be 3 more words, and here I have actually more. So I have 1, 2, 3, 4, 5, 6, and these 3 are unfortunately out of luck because we define the truncation to be true, which will basically take and remove everything after the maximum number of words that we defined. So in this case, we'll have something that looks like this. And that's basically happening inside of this tokenizer. Now, these words will become numbers, as we said, but just for a gist, this is what happens in these 2 arguments as well. Okay, after that, I want to take this tokenized batch, and then take a label. And then what I'm going to do is take str to int of label for label in batch of label. Okay, and then return tokenized batch. So what I just did in here is this. I iterated through my batch of data that, label like this. So I iterated through my batch of data that we just received in here. And for each label, I checked out what's its own ID, like 0, 1, 2, 3, 4, 5, 6, by taking the string to integer and taking actually the key, which is my label, and just replacing it with the number. And afterwards, I'm completely replacing it in this tokenized batch label. So instead of having these numbers, strings, I would have a number. And that's basically my full function. Okay, we survived one of the toughest parts. No, it's not really the toughest, but we survived a longer part. Do you have any questions? Let's check it out. Okay, we have a question from Alexander. Where is a list of tokenizers, or how do I find out the best tokenizer for training? Okay, that's a great question. So mention. Okay, I'll mention again, Phil. No worries at all. So let's first mention the Alexander's where can we find the tokenizer? Once you are in a Hugging Face, you have so-called models, and those models differ for many different reasons. Like in this case, we have like 650,000 models. And let's take a look at BERT. So BERT, this is what we are using right now by Google. And when you scroll down, you will see the way that they actually implemented this. See this? They will define what is the tokenizer. Okay? So you are actually following along what is provided to you by the documentation for every single model. So if you choose BERT as we did today, you would load the BERT and you would load the tokenizer for BERT as well. Okay, so basically that's where to find the tokenizers. You don't need to find what is the best tokenizer. Every model has its own tokenizer, so we can't actually change the tokenizer, from here to there. We just need to comply with the model's tokenizer that we are provided with. But yeah, that's how to find. If you're loading a certain model, you would basically load the same tokenizer as well. That's it. Now, the second question would be, okay, how to find the best model? Well, through trial and error. Because in this case, we tried the BERT, but basically, maybe we find out it doesn't work that well. So we would go back and say, oh, but I don't know any actually models that are performing classification on text. That's fine. Here is the text classification section that you can go and see right there what are some other models that we can choose from, like Roberta based Go emotions. Maybe that's a good one. Then we have this CryptoBert, then we have this MXBay re-ranked, and so on and so on. There are many different models, like under just text classification alone, that we can potentially choose from and check. But whenever you choose a model, you will see that it has its own tokenizer aligned with it. Okay, so here it is. You load from the tokenizer and you go from there. Okay, great. Now there is how do you know what your list of emotion is complete? Yeah, that's a great question again. So I checked out this data set right here, and basically I found out from the documentation. Here is the list. Here is the link to the data set. And I looked at the documentation and saw, like, here is the list right here. That's it. I have notes on this side, so I'm following the notes as well. But basically, when I created notes, I checked out this documentation that I just sent you. And yeah, every data set has its own documentation, so you can check it out. There are a couple of great questions. So Phil, I'll talk about tokenizer in just a second, but let me read all the questions there. Shahir said, why do we need to set truncation to be true when it removes essential pieces of text? Shouldn't we be trained on all the data? Of course, that's a great question. So let me answer Phil's questions first about tokenizer, and then I'll jump there. Okay, so what is a tokenizer? Basically, when we have a data set like this. Okay, so we have a data set that looks like this. I am driving this car to the, I don't know, UK, or to the UK, I don't know. Then he is eating his pie. Okay, she is playing a piano. Okay, so this is your data set. Now, imagine that you are training a model, any model. It can be a BERT, it can be anything else, to generate this piece of text. Now, you would split up two different sentences and say, here are my 3 samples. This is my third sample, this is my second sample, and this is my first sample. And now you need somehow to communicate that these are actually something that makes sense to my computer, because computers are stupid. They don't really know the text. We humans do. But when you are just writing the pure text to computer, they don't really understand it. So we need a mechanism to go from text to actually numbers. And in this case, what we need to do first is this. We need to find out the list of all unique words in our data set. So here I'm going to write I am driving, driving this car to UK. Then he is eating his pie. Then she, now is already exists because is here. So I'm skipping that. Then playing a piano. Okay, so this is our list of words that can represent all of these sentences. Now, in the reality, we would have millions and millions of these sentences, but in this short case, we have only 3. So we have a list of words. Now, we can't just push it to the model and say, this is a list of words that you know. You need to mark it with some numbers. So this is basically IDs. So this will be 0, this will be 1, this will be 2, this will be 3. Let me copy and paste this a couple of times. Okay. Oops. Okay. Are following along? You're there. Great. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and finally 15. So the tokenizer comes right now. Tokenizer, woohoo! So enter tokenizer. Tokenizer has this information, that goes and says, what words do I actually know? I might not know all the words, which is completely okay, but I do know all of them or most of them in this case. So when this sentence comes my way, instead of keeping the text, I'm going to take this tokenizer and say, hey, go to your list of words and change this to numbers. So I becomes 0, M becomes 1, this becomes 2, this becomes 3, 4, 5, and 6. So instead of having the words that we had as is, we are taking this list and it will convert them to a set of numbers, basically, for us. And this can be pushed to the model itself, and the model will do some its magic internally and then push out the output. Does it make sense? So that's basically what tokenizers do. Any tokenizer, whatever you choose, that's basically it. Now, each model will take different set of words. So when Alexander asked, okay, what is the best tokenizer and where to choose them, whenever you train a model, you basically have a different tokenizer that will basically map out all of these words by itself. Basically that. Okay. And now to Shahir's question, I think. Yeah, Shahir, yeah. So he asked, why should we basically truncate some data? Now, there are 2 different sides of the answer. The first answer is this, the simple one. When people at Google trained the BERT model, in this case, they trained it in a way that they basically said the maximum number of words or these numbers that you can accept is 512. So max 512. That's it. Okay? So anything above that, I can't accept. So if you want to push some text to it, either split it up to different segments, which is completely okay, or in this case, because we are doing classification, we unfortunately can't really split it into two different cases. We just need to follow along. And in this case, you basically go and say, okay, I'm going to truncate to the maximum of the model. So if you have a text that goes blah, 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 and then continues for max words of maybe 500, 550, well, unfortunately, we need to truncate to 512 because that's the maximum of the model. That's the first side of the answer. The second side of the answer is because when you add zeros, because for example, you have these three sentences, they're pretty similar in number of words in the data. So 1, 2, 3, 4, 5, 6, 7, 5, and then 5. So either add 2 zeros at the end of each of these sentences, or remove these 2 words and basically leave it as is. Zeros or padding to match the maximum amount will actually add noise. So your model, if adding too many zeros, imagine that you need to add this many zeros. Well, in that case, a model will focus on zeros. And this part of your input will basically be forgotten. So we are truncating to some arbitrary number or model's biggest number so that we don't add as many zeros as we need or should. Depends on how you look at it. Does it make sense? Yeah, yeah, exactly. Mehari, tokenizer splitting strings into subwords, token strings. Yeah, converting tokens strings to IDs and back. Yeah, exactly. Tokenizer is doing just that. Yeah. Now some tokenizers will do and split this driving maybe to 3 different parts, like drive, and then you will have ing as like this, and then that's called tokenizer with a subword tokenizer. Now some tokenizers are even a character based, so basically you would have like this and so on. It really depends on the model that we are using. We don't really care about let's say if you are not creating your own model, you don't really care on what granularity level you are splitting your words. But in this case, like, you can be a subword, you can be a full word as this, or you can be a character level. So it definitely comes only to the model and the choice of the developer who created that model. So that's the only kind of a difference and the way that you should navigate these tokenizers. But all of them are working the same way. Yeah. The only difference is this, the granularity level of splitting. Yeah, exactly. Thanks for providing that. Cool. Okay, so I'll keep this up so you have the notes. Okay, great. So let me add one more code cell where we are. Okay, we need to go and convert our data set, the raw data set, to actually tokenized one. And in this case, I'm going to define tokenized train data, and I'm going to define this test data here as well. This will be really simple. So I'm going to take train data set, okay, and then you need to map, and we are calling this function. And because we are working with a batched information, you need to provide batched equal to true. I'm going to copy the whole line and paste it below. And this will be test data set. Execute the data. Execute. Surprise. Okay, so we missed one. Oh, okay, I misspelled. Okay, great. So let me do this again. Okay, here it is. Amazing. And voila, we have the tokenized data set. If I showcase the same example, you will see that all zeros that we just basically pushed, that's why we are not adding as as many as possible. But yeah, that's basically tokenizer output. And here is the only string. So anger, and as you can see, label is free, and then input IDs are a couple of IDs, and then many zeros. Yeah, because of that. Okay, let me scroll back a bit so you can copy. Everything clear so far? Following along? Have you managed to execute yourself? So far? Cool. Any questions for me? Okay, please let me know if you have any questions. Great. Okay, so now that we have our data set trained, prepared, it's time to enter the model. So importing the model. And the model is going to be birth-based cased. So from transformers, import auto model for sequence classification. Let me choose that. That's it. Execute that one. I'm going to copy that. And then model will be from pre-trained. And here it is, birth-based. Oops, not based, but based cased. And then we need to provide number of classes or labels, and that's going to be for this data set 7. LABL bells, like this. Okay, so what I did just now, I put here the birth-based cased model, then said from pre-trained, this should be the same as our tokenizer. So once you import the tokenizer, as you can see right here, the name of this should be the same or matched as our model itself right now. And this number of labels is equal to amount of our labels, of course, in the data set that we are currently using. So in this case, it's 7 because we have 7 emotions. Good so far? Please let me know if you managed to import the model. Okay. Great, thanks. Okay, now we need to define something called training arguments. So from transformers, import training arguments. And then this training args is going to be equal to training arguments. Now, these training arguments can be really long, And as you can see, there are many training arguments that you can provide. Now, there is great documentation from Hugging Face that you can read through later if you want to define more nuanced and stuff like that when you start playing with the training your own model. And through next couple of sessions, we're gonna go really deep into these training parameters. But if you don't want to wait, you can go to documentation in Hugging Face and read it yourself. But these training arguments are nothing else but actually helping us define what are the criteria that you would like to use to train your model. Now, in this case, I'll keep everything as default so we can keep that part simple for today. Now, the only thing that I'm going to define is output dir. Output dir is going to be my first model or whatever. And these training arguments are ready. However, we need to import one more thing to make it work. And that one more thing is called evaluate. Now, if we take a look at pip install evaluate, you will see that there is one more library called evaluate created by Hugging Face. And this evaluate is a library that makes evaluating and comparing models and reporting their performance easier and more standardized. And if we use this evaluate, we can define our accuracy function. And not only that, but once you push the model to the Hugging Face that we want to do at the end of this session, you would have already pre-generated statistics about your model, which is crazy great and also really simple to do. Okay, so I'm gonna install it from here. And the next thing for me is to define a metric. Now, I'm gonna import one more thing, and that's NumPy. So import NumPy as NP and import evaluate. Okay. These two libraries will help me, evaluate the metric. Is the accuracy something that I would like to check? Well, yeah, because we have 7 classes and I would like to monitor what is the accuracy of our model. Now, in this case, the metric is going to be evaluate dot load accuracy. And that's basically it. In one line of code, you define the script to check the accuracy of our model. Any questions? All clear so far? We are coming really close to starting the training process. Bear with me, guys, a couple of more minutes, and we're going to be there. So the next step is to define compute metric. So define compute metric. Now, this is basically defined by evaluate function. And compute metric, you can name it whatever you like. You don't have to name it as this. You can name it just metric, or, well, you can because I use it here, but compute accuracy, for example. And then this will be our models, predictions, as well as the concrete training arguments that, or not training arguments, but the data set that you would like to match. So here you will need to unpack, because everything is underneath one. So logits or models predictions, and then of course labels. And that's going to be eval pred. Now, as I said, you can name it whatever you like. You don't have to name it as this. And then predictions are going to be np.argmax of logits of x is -1. I did a weird thing right now. Let me let me implement one more line, and then I'm going to explain what I just did. Return metric, which is this one, dot compute predictions is equal to predictions. And then here I have references. That's gonna be my labels. And that's basically it, our compute function. So what I did here is this. First off, we received the predictions of the model, which we called logits, and then we have labels, which is our data set. Now, both of them are stored to eval_pred, which is the input to this function. Now, we are not doing that manually. That's something that's done by Hugging Face. So we are out reversing those two. And then, because you will have something like this. So because we have 7 classes, we will have model predictions that looks like this. So for each for each prediction, we will have, let's say, 0. Then here 0.001. Then we have more and dot 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 for every single class. We would have a similar thing. Now we would like to have from each of the predictions the largest class, which is, for example, this. So argmax of this will return argument or ID, basically, of largest probability. So if this is a 0.31, well, this is the largest probability, and that's what we take. Okay. So this basically does that. We are taking predictions, and then from those predictions, what we do, we put everything under our accuracy that we loaded from our evaluate function. That's basically it. Nothing spectacular. Okay. We have a question. When you say class, what do you mean? What do you refer to? Oh, that's a great question. So we are referring to basically a prediction of the model. In this case, let me scroll up a bit. These are our basically predictions, what we can have. This is a class. So these are classes or labels. Class or a label is the same thing. Depends on how you call it. So class would be a label. And in this case, we have 7 classes / 7 labels: net, neutral, sad, anger, disgust, surprise, fear, happy. Okay. I'll take a quick pause here to see if you caught up. Phil, Alexander, Brian, Daniel, following along? Yeah, all good, cool. The rest of you guys, do you have any questions for me? Should we continue? All good so far? You managed to implement? Nearly caught up? Okay, I'll wait a couple more minutes, no worries. In the meantime, please let me know if you have any questions, guys. I'll keep this up for a couple of more minutes so everybody can catch up. Yeah, we have, let me see, 2 more things to implement, really short ones, and we are ready to click train. So the next thing to implement is, again, training arguments. And then we basically, we define the training arguments again, because we can use one more thing, which is evaluate strategy. And we are nearly done with the trainer. We basically put everything together and we are done. We just click train. Getting dinner, so don't worry. Okay. Okay, cool. So I'm gonna scroll up and copy this and paste it in below so we don't have to re-implement it. And the only thing that I want to add right now is evaluate strategy. Now, evaluate strategy basically means that how often we will need to check up with our testing data to see if our model performs well. And by default is batch, but I want to check it to epoch because I would like to see one full training cycle and then check it out on the test data in this case. So I'm gonna I'm gonna use it again. And the next thing and the last thing that we need to implement before we click train is this: from transformers import trainer. And I didn't define this correctly. Transformers, like this. So this trainer doesn't do anything special except puts everything together. So what I'm going to do right now is trainer is equal to, trainer. Okay, so the first argument is model. We need to provide our model. Then args, and that's our training arguments. Then we have our train dataset, which is our tokenized train data. Then we have eval dataset. Every time when I say eval dataset, I almost hear myself saying evil dataset. Yeah, not good. Tokenized test data. And finally, the last thing is compute metrics. And that one is compute accuracy function. We just provide a function and we are done. So we put everything together. Great job so far, guys. We have a trainer done. Execute that. And we are now ready to call to train. And here it is. If nothing breaks and it works, great. Cool. Yeah. See, I'm not the only one who hears evil. Okay. So our model is training. It will take a long time. It will take about 2 hours to finish training. So we, of course, won't wait on the call for 2 hours, but you can leave it up. Yeah, but basically that's it. Your model is training. It will reach this point and then do evaluation step and then basically finish with that. Okay. Do you have any questions so far? Okay, we have Mehari. What kind of data would an email? I don't know. Like not clean data set. I don't know. Like somebody who is actually like trying to screw up with us. How do we save it? Then you can use it. Oh, so Alexander, that's something that we're gonna do right now. So because this will take a long time on at least this GPU, I'm gonna stop this training process. So please, you can continue later, or you can circle back to this. No worries. Like you can just retrain it whenever. We didn't wait for a long time, but now we are actually ready to push this model to our Hugging Space or Hugging Face space with a one line of code. So the first step is to log in. So here I need to provide Hugging Face dash CLI login. And with this, here, I'm gonna provide this in here. So I need to provide a token. So this token can be found in my settings. So let me go there. If I go to settings, so here is my account. Let me go from the home page. So here is my account. I would go click on my icon, and then I go to settings. Underneath settings, you will have many things to change. You have this access token, and you have, well, in my case, two access tokens. I'm going to create a new one for you to see, but basically you can create a new token, and then you can name it whatever you want. So let's say test lab token, and make sure that you are actually starting to write token, because you unfortunately can't use read and write. Well, you can use like this, but either make sure it's best case to create two tokens, like as you see right here. One is read and other one is write. So let me create a write one. So with a write, you're pushing the models to Hugging Face, you are saving them there, and so on. But once you want to read it back, you basically use the other token for read. So generate token, and this is my new token. I'm gonna copy it, and when I go back to my Google Colab, I can paste this token in here, click enter, and I should be logged in no time. So let's wait. I don't know, something is happening. So there is a question, do I believe that Hugging Face will eventually be similar to popularity with GitHub for ML projects, where ML engineers, data scientists will be uploading cool projects they have built using Hugging Face models? I think we are already there. Hugging Face became like a really fast, the main go-to thing for all machine learning, data science stuff. The only kind of a limitation so far is you are kind of locked in the ecosystem of Hugging Face. So you are like, there are many models that are not deep learning and like neural networks. They're much simpler models than that. So for now, those are still hosted on the GitHub, and then you have that kind of a dispersity between those two ecosystems. But in the long run, I don't see why not. Yeah, and I don't know. I don't see why is this not logging in. Okay, so let me try again. Okay. Oh no, why? Okay, I'm logged in. Great, login successful. So the only thing that we need to provide is model dot save pre-trained, and then you provide training test model, or whatever is the name, push to hub true, and private to true. That's it. Those are free arguments. You can name this whatever you want. Push to hub is true. Basically, we want this to be in the Hugging Face, and private is true if you want your model to be private for only your account. And when I execute this, it will take a couple of minutes, I think. It really depends on the model, how big it is, and your network and stuff like that. So in this case, it's 433 megabytes, and yeah, I think that's it. And then when I go to my account, let me go to my account, you will see that training test model, the one that I just created, is there. I have everything pushed in here. How great is that? one line of code. That's it. Okay. So we successfully pushed the model. And now you can play with how well it's designed and how well this is created for you. Now, this is private. And the first thing first is something that's called model card. Now, every data scientist, when working with the company or by itself, one of the things that they define is called model card. They have Hugging Face has amazing model card kind of a template that's defined because we use that evaluation library for us. So here is the whole template, and here you see model description. This is a model card of a transformer that has been pushed to this hub. You can click here, edit model card, and it's kind of a README file that you can change and say, hey, this is a model card, blah, blah, blah. So here are the links developed by whatever, Luca, funded by whatever, something, and so on and so on. Of course, you don't need all of this information. Some are optional. Model type, BERT. Language, well, I don't know. License, free for all. And so on. So you get the gist. Now, amazing thing about this is actually the fact that they helped you with all of the things to change and play with. And also this you should only follow along. That's it. Now, all of your libraries, when you go to your project that you just defined, you will have this model card. This model card is a go-to thing that every potential employer will check out to see how well you actually go about your research. And it will summarize your efforts and what you tried along the way once you start building these types of models. Now, there are files and versions, and this will be your model. It will be configuration. All of these are generated by Hugging Face. This model is the model itself, as you can see here, 333 megabytes. Uploaded from BERT for sequence classification that we just use, and so on. Community is somewhere that you can build like new discussion and stuff like that. It's mostly to like kind of a GitHub community page. And settings is, well, for settings, like what is the access points, webhooks, and stuff like that. Now, I never checked settings. In most cases, what I do, I create this privately, then I check it out, push it to there, change all the model car stuff, and push all the project details, and then I push it to public, and then share it within my CV or my like LinkedIn page and stuff like that. So please, when you create your own models and once they are public, I would love to test them out and use them. So make sure to share with me if you like. So we have a new question, and that's, how do we determine when to push our models code to GitHub and when to push to Hugging Face, or should we do both? I would say do both. Well, if you are using Hugging Face models, I wouldn't go with the GitHub. I would always go to the Hugging Face. And Hugging Face is, as I said, is a kind of a closed environment for Hugging Face models only. So if you are using something else that's not Hugging Face directly, it's directly limiting on how much you can actually push to the Hugging Face. So I would say like combine. But Hugging Face is a great opportunity for all of you guys to build your own portfolio. And that's my goal. Like, we just learned how to push it. We will learn a lot more on how to create a great project and what are the great ideas of the projects on the Hugging Face in the future weeks. So my goal is basically to create a lot of projects with you in the next like months. And yeah, every couple of weeks we'll sit down, create some interesting projects, and once we go from these kind of necessary things to go over in the beginning, we'll just focus on the simple projects and then build from there. How do we differentiate ourselves on Hugging Face to set us apart from others using these models? Great question. So there are a couple of ways. I would say build data sets. Build your own data sets and start building on those data sets a couple of models. Now your question is how to build a data set. That's something that I want to cover next week. Not next week, next session. So next session will be on how to create your own Hugging Face data set from like general data from the internet. I'm gonna show you that, and then build some model on top of the data. That's one thing. The second thing is build a simple projects with like different visualize, because most people will push the code to Hugging Face with like just fine tuning a model and stuff like that, and that's about it. But I would say go further than that and build an interface um, to like to that model, like send a request from like a website or a recommendation system or something like that, and then basically go from there, and then yeah, build an interesting interface, and then record a video, push it to the YouTube, let's say, and then add it as a one showstop at your repository at Hugging Face. So you're explaining what you built, and that's it. Model is not defined. I'll circle back to you, Mahiri, in a second. But yeah, so basically that's how you build it. Oh, interface can be anything. It can be like simple web application. It can be like there is a great called Stremio. Not Stremio. What? Streamlit. Let you can create simple applications out of these kind of things with the Hugging Face models, like with no basically no code, like a couple of lines of code. So let me do this for fast. So let me try to find if I have a model there in Streamlit. I think I have this one. Yeah. So I have this kind of a app that has two machine learning models in the backend. Like you can upload a file and it will classify web traffic and explain what it is for executives. It was some course, and basically that's basically it. And then here you have customer segmentation. You would upload a file, and then another model will basically upload showcase your kind of a pieces of data where it lands. I need to find those two files to demonstrate. Once I do that, I can show you the next week. But basically, this is a Streamlit application. I can teach you that if you're interested. Yeah. Oh, you can't see my screen? What? Really? Oh, I stopped the sharing screen. Thanks. Okay, cool. So uh, let me reopen then, and then actually share my screen. Let me do that. Okay, so I have this app that this one. Oh no, this one, and you have a simple interface that you can build in like two lines of code of Python that goes like, for example, like this. You can upload a file, upload there, and then basically it will run one machine learning algorithm. And then if you select customer segmentation, it will run the second one. And everything is in real time, and you can deploy to basically millions of people. The only thing that I can demonstrate today is I don't have on this computer these two files. So yeah, basically, once I have gotten those files, I can demonstrate a full prediction. Yeah, yeah. Okay. Um, stop sharing. I have a couple of questions, Shahir, before that, and then I'll circle back. So, Mehari, it's the name error model is not defined. That comes from maybe you define it in some other way. Let me go to my code, and then I can show that to you. So here, I define this model equal to auto model for sequence classification, and that's this model basically. So that's the model that you're trying to define. Please execute this line of code. I can copy and paste to the chat. So here is the model, and once you have that, everything below that should come into places and then successfully execute. Please let me know if you successfully done that. Then we have a question: is how simple or complex do our ML models and datasets have to be in order to post on Hugging Face? It doesn't have to be complex at all. Like Phil, it really comes to the business value and solution that you're trying to solve. Like you can build a really, really simple AI model for like a predicting between apples and oranges, but it actually works for people that needs to have like apples and oranges. That is more than enough. So be focused on problems that you're actually interested in. It doesn't have to be like a really crazy stuff that people are thinking or craving about. You will first of all build to that part. The second of all, it's much better to be focused on something that actually keeps you up at night, like a problem, than just follow in the footsteps of most people that are just doing something for themselves. So if you're interested in, I don't know, that cats or dogs, focus on that. Create a simple classifier between cats and dogs, or just dog breeds, stuff like that. So yeah, it doesn't have to be at all complex. For data sets, doesn't have to be complex at all. You can upload it privately for only you, for link, so unlisted, or it can be no, that nobody cares about. Like you are trying your best. Everybody does. Who will laugh? Nobody will laugh. Everybody's learning. I'm learning every day. We all are learning together every day. So do your best, and you're the yeah. That's the best you can do. And it's nothing is simple, nothing is complex as long as you try your best. That's it.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.